Here we go, never end. So this is actually kind of similar to what we have with 6. Use the graph below to find the equation of a line that is perpendicular to the given line and passes through the point. Great. When we write an equation of a line, just like we did for the previous problem, what things do we need to graph a line? You only need 2 things. What are they? Slope. You need that m. And what else do you need? Intercept. Those 2 things. The equation of a line, remember, is y equals mx plus b. The 2 things you do need are the m, which stands for slope, and the b, which stands for y-intercept. Great. We want to make a new equation that is perpendicular to this given equation and passes through that point. Problem is this. Do we have a slope?
Nope.
And we find the slope on this line.
Yep.
How do we find that slope?
Count down the numbers.
Yeah, I got to figure out how to get from that one dot to the other dot. And that will represent my slope. So I go from here to here, what do I have to do? I have to go down. Because I'm going down, that makes it negative. Very good. So my slope's up here. I went -4. And I have to go over to get to that dot. And I go 5 in that direction. So my slope is -4 this. That's the slope of this line. But we don't want to graph that line. It's already there. We don't need it. We want to graph a line that is perpendicular to it. So what changes with slopes when they are perpendicular? What do you have to do? You have to flip them and then change the sign. Call it opposite reciprocal. Because this one is negative, the new one's going to be positive. And flip that fraction. What do you get? 5/4. That's going to be our new slope. And Megan was correct to say we also need that y-intercept, which is b. Very tempting to choose this point over here, which is at 0, 3, but that's the y-intercept of that line. We don't care about that line. We want a new one. So what we're going to have to do is we're going to have to use this point up here that hasn't been used to find what that b is. What is this? What do these 2 numbers represent? What are they? X and Y. So this is my x. This is my y. I'm going to use those 2 points, x and the y, along with my m, in the given equation that we have up there to figure out what the missing b is. So let's do so. So I'm going to take that equation, y equals mx plus b up there, and I'm going to plug in these values x, y, as well as the slope. So y is 4 is equal to a slope of 5/4 times x, x being 4 again. And that equals plus b. So that's what we're trying to do. Those together, that's the formula. The only variable we have is b, so when we solve this, we'll get b. So time to use your calculators, calculate things up. What is 5/4 times 4? 5. Yep, 5/4 times 5, or 4, is 5. 5 times 4 is 20. 20 divided by 4 is 5. Plus b. Baby bear problem, one stepper. What do I need to do?
Subtract that.
Subtract that. Keep going. 4 minus 5 is -1. So -1 is b. A lot of students tend to stop there. You're almost there. You're so close you can taste it. But I now have my b. The b is -1. Because I have my m, because I have my b, I can write it in its standard form now. So when I rewrite it, go to that equation, return y and x where they were at, so they're back to y and x. I put my new m in there, 5/4, and put the x right behind it, and then my b of -1 goes behind that. That is an equation of a line that's perpendicular to that line and goes to that point 4/4. Very similar to the one before it we did, but the one before it was parallel, so we didn't change the slope. That's exactly the same. Questions? Next one.
On number 8. We want to find the area of this triangle graph below. Whenever you're trying to find the area of a triangle and the lines are not nice, neat, and straight, you're not using Pythagorean theorem. It's super tempting to use it. You're going to use that on something else. So go ahead, when you're trying to find the area of a triangle, draw a box. Like so, around the triangle so the vertices touch the edge of that box. Right? what we're doing is we're trying to find the area of that box and then subtract the area of these three little triangles, and then that will leave us the area of that middle triangle. So find the area of that box first. Draw your box and find the area. What's the formula for area of that kind of shape? What's the box shape, Megan? That's for triangle. You're on the right track. For a square, rectangle, triangle. You're on base times height. For just a box, we use base times height. For triangles, we're going to use 1/2 base times. All right. So, what is the base of our box? Okay. What's the height of our box? 4. Right? So 5 times 4 is what? 20. Right? There's the area of the whole box. After you do that, your next step, find the area of these triangles right here. So you're going to find the area of this green triangle. You're going to find the area of this purple triangle. And then you're going to find the area of the orange triangle. 3 triangles right there. Okay? And like we said, the area of a triangle is 1/2 base times. Okay? So let's take a look at the green triangle first. What's the base of the green triangle? 5. What's the height of the green triangle? 3. Okay. Multiply that together. 1/2 times 5 times 3. Okay? 15/2. Which is a decimal. Or no, it's 7.5. Very good. Okay. Okay. Repeat that same process to find the area of the purple triangle. So, what is the base of our purple triangle? 3. Okay. What's the height of our purple triangle? 1. And what's 1/2 times 3 times 1? And repeat that same process with the orange triangle. What is the base of the orange triangle if we count? 2. What's the height of the orange triangle when we count? 4. And then 1/2 times 2 times 4 is what? 4. You just go through, find the area of the box that you draw around your triangle, and find the area of the other 3 triangles, and then you're going to take those values and subtract them from the area of the box. And your leftovers, whatever your answer is the area of this middle triangle, which is what we are trying to find. We're going to find the area that's in the middle triangle right there. Okay? So what do we get when we do 20 minus 7.5 minus 1.5 minus 4? You got it? What do you get, baby? 7 units. Squared. There. Same exact steps every time you just are going to be dealing with different numbers and different triangles. Same exact steps. Draw the triangle in the box, find the area of the box, find the area of the little triangles on the outside, and then subtract.
So on area, you're not going to be doing the Pythagorean theorem. You're going to be subtracting things off of a total amount. It's a helpful hint for that. You see area, don't do Pythagorean theorem. Unlike this next one, which is find the perimeter. So, when I'm asked to find the perimeter, what formula should I use to find these? Pythagorean theorem. Starts with a P, starts with a P. Think about that. That's what I need to do. I need to find the distance of these sides. Again, how do I find perimeter of anything? What do I need to do? I find them, then what with them? I add them all up. I want to figure out the distance surroundings. Now, what's really nice about this polygon we got up here? Correct. One of the sides is very easy to count, so I do not have to do the Pythagorean theorem 4 times. Sometimes you will, sometimes less, whatever it is. But this one I only have to do it 3 times. Let's find those 3 sides. I'll start with AB first. So let's define perimeter, Pythagorean theorem. Pythagorean theorem deals with right triangles. So we're going to make right triangles. So from A to B, so it's kind of doing like the slope of it. Trying to figure out what it is. And that formula is what you're given. You're given that. It's A squared plus B squared C squared. Probably some of you guys have that in your memory banks. When you guys dream, you probably have nightmares about the Pythagorean theorem. So, how far up do we go to get up to the same level as B? How high up do we go? 6. So I went up 6. That is one of my legs. So when I plug in the formula, it's either the A or the B. It doesn't matter, they're interchangeable. We'll call it the A first. So 6 squared plus, how far over do we go? 2. That's my other leg. 2. C squared. Nice thing is, you have calculators, you can plug that in as you see it and get the answer right now. For the sake of people who don't have calculators, we're going to solve this out a little bit, not too much. 6 squared is 36, plus 2 squared is 4 equals C squared. Add these together, 36 and 4 give you a 40 Cracomunde, C squared. I want to get C by itself, I need to square root on the squares. So I now have C is equal to the square root of 40. It will tell you that it'll tell you to round to the nearest whatever. So you don't have to leave it in simplest radical form. So we don't have to rationalize this. Meaning do the little thing about the perfect square goes into it, blah, 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 all that jazz. So this is plenty for us right here. All right? So when we're done now, let's find the next one, BC. Same process. Figure out how high I have to go, rise, and run over. One of those legs there. Okay. And we're talking BC. So how high up did we go? 6. Agree? How high over did we go? How high over? Doesn't make sense. How far over? 8. Good. Again, those represent the legs. So I'm going to say 6 squared plus 8 squared equal to C squared. Solvify 36. Let's go to the next one. We already found that. What's 8 squared? 64 equals C squared. 36 and 64 give me a hundo equals C squared. We know we're going to square root. Hey, does the square root of 100, does that work? What is the square root of 100? About half. 10. It's 10. And some of you say, yeah, I got that a long time ago. How did I get that? Well, because I know this is a 6, 8, 10 triangle. It's a P-trip. It's a Pythagorean triple. So we could have done that, but no big deal. We found it anyways. All right, let's find the last one that we need to find is using the Pythagorean theorem. And it looks like a little segment CD. So I'm going to, I'll stay on the outside. I'll do this one. I'm going to go down and over. How far down did we go? Use your resources. You don't have to worry about that. The negative, just there's 12. Again, as we say, look at the other side. 6 and 6 together. That makes it a total of 12. How far over do we go? 2. Those are my legs. Plug them in. Let's roll. 2 squared plus 12 squared equals C squared. 2 squared is 4. What's 12 squared? 1 foe equals C squared. 1 foe. A lot of foes in there. 148. C squared. Square root. Coming out pretty good out there. C equals the square root of 148. Okay, those are the 3 sides that we did need to do Pythagorean theorem for. There's one more side of this polygon, and that'd be AD. What am I writing? That's not an A. It's a triangle. AD. Well, how long is AD? What's the distance? Just count. It's 8. 1, 2, 3, 4, 5, 6, 7, 8. It is 8. No big deal. And we already established that perimeter is you just add up the distances around. I don't care that there's radicals there. You can still do it. If you're using with a TI-30, just make sure you close your parentheses when you're doing this. Well, let's add it all up. So when I do so, I'm going to do radical 40 plus 10 plus 148, radical 148, plus 8. That makes my perimeter approximately, round to the nearest tenth one decimal place. When I type all of that in my calculator, I get this number approximately 36 point, it's like 36.4900132, right? That was close. Huh? Pretty close. There's double zeros in there. Alright, questions of that? Okay, let's move on to number 10.
If we look at 10, since AB has endpoints at -5,9 and 13,3, what would be the slope of a line that is parallel to AB, and also what would be a slope that is perpendicular? Well, in order to decide what slope would be parallel and what slope would be perpendicular, we need to figure out the slope of our segment AB. Does everyone remember what the formula for slope is? Okay?
x1, x2 minus x1.
You are super close. That's the bottom part. So it's going to go on the top. X is on the bottom, Y is going to the top. So then go ahead and label. 1, Y1, X2, Y2. So we plug that in, what's the top going to look like? Yep, 3 minus 9, very good. What's the bottom going to look like? 13 plus 5, very good, because you have the double negative. It's 13 minus -5. That turns to a positive. So clean it up, what's 3 minus 9? -6. What is 13 plus 5? 18. What must we always do with fractions? Yeah, let's simplify down to 1/3. So that's the slope of AB. If we want a line that is parallel, we know about parallel lines and their slopes. They are what? They're the same. So if our AB is -1/3, the slope of a line that's parallel is also going to be -1/3. Parallel lines have the same slope. For a line that's perpendicular, what do we have to do with a fraction? Flip it. So 1/3 becomes 3/1. After you flip it, what happens to the sign? Good, it changes. So our original slope's negative, so our new slope's going to be positive. So you can leave it like that, totally fine. Or 3/1 is just 3. Either one's fine. Questions over that one? Similar one to that on your test. Okay. You flip it over to the back. There's one just set up the same exact way that was on your first test, and there's one that's set up the same exact way that's going to be on your retest. What we noticed a lot on the original was for like B. Determine if it's a rectangle. A lot of students just said yes, 4 right angles. But there's no math there to support that. So you have to make sure, in order to get full credit, you have to show the math, then you have to say yes or no, and then you have to have an explanation. Okay? So diagonals, bisects, 4 right angles, something like that, to get full credit. Okay? If there's no math, and you just have yes, diagonal bisect, with 0 math there, you're going to get 0 points. Okay? You have to show the math to back up your answer. Okay? Questions over that? And make sure you just make these changes. This is A, B, C, and D. So kind of answers this.
All right, so we got this quadrilateral ABCD. What do you think is the first thing we should do? We've been doing this entire unit. Plot the points. Let's put them on the paper. All right, so let's see what we got. A is negative 4, 0. There you go. There's A. B is at 4, 3. 4, 3. Oh, there it is. C is at 7, negative 5. There's that guy. And D is at negative 1, negative 8. D. Bingo. Okay, there we go. So what are you, some of you guys saying? Yep, that's a rectangle. Done. Well, you'd be wrong. Need those three things to ask for. Need the math, need the yes or no, need the explanation. Let's go here. Well, we want to first see if it's a parallelogram, because without being a parallelogram, it's none of those things. So that should be the first thing we prove every single time on this. How do you prove that something is a parallelogram? That's the first step we've done on all these. I need to look at its, what? The diagonals. What about those diagonals? You're exactly right. They should bisect each other if they are, if it's a parallelogram. So we're going to look at these guys and see if they are bisect each other. All we have to do is, once we do that, is we got to find the middle of those segments. If we can find the middle of each segment and they happen to be the same, then they bisect each other. So the first segment we're going to say is AC. We're going to find that for that formula of that. And the other one is going to be BD. It's going to be BD. Let's go here. AC. Okay. Well, how do I find the midpoint? What is the midpoint formula? What do I need to do to find the middle of something? Give me a helpful hint. It's going to look something like this. Megan, you're thinking it. Exactly right. The average of the x's, average of the y's. So I'm going to put the x's, add those together, divide by 2, do the y's, divide by 2. So since I'm doing point AC, well, look up at A. What is my x value in A? Negative 4. I'm going to do negative 4 plus, what's the x value of C? 7. There we go. I'm going to do the average of the x's. Also going to do the average of the y's. Going back to A, what's my y value? Plus my C, what's my y value? Negative 5. There we go. And again, we're going to solve this a little bit. So negative 4 plus 7. Or 7 minus 4 is? What's it? 3 over 2. 5 minus 0. Negative 5. So divided by 2. Do those reduce down? They don't. So we're going to leave it like that. We're going to look at BD. Let's see if BD gives me the same midpoint. If it is, that means they bisect one another. All right, let's go. Same exact formula. Divide by 2, divide by 2. BD, what's x value in B? It is 4. Plus x value of D. Negative 1. Back to B. 3 plus negative 8. Reducify. When I do so, 4 minus 1 gives me a 3 over 2. So far, so good. 3 minus 8. Hey! What do you notice? They're the same. These dudes are the same. So since they have the same midpoint and these intersect each other at that point, so is this a parallelogram? Yes. We could say yes, parallelogram. Now you need the reasoning. The reason is the diagonals bisect. So the diagonals bisect. Cool. We now know it's a parallelogram. We got to continue on. I still don't want it. Got to continue on. Now we got to see if it's a rectangle. Okay. What makes a rectangle a rectangle? What? L. 4. You were trying to piece it together. I like it. You're pointing to my left, though. Really what threw me off. There we go. All right. Angles. 4 right angles. That is correct. A rectangle does have 4 right angles. But the nice thing is this, because we know it's a parallelogram, there's another rule that says if I have 1 right angle, then I have 4 right angles. So all I have to do is find 1 right angle. That's why proving this works is so nice, because I only have to do 2 things here, versus if I had to do the sides, I had to show that opposite sides are parallel, I had to find 4 slopes. Again, if I hop down to see if it's a rectangle, I'd have to prove that 4 of these were perpendicular to one another. So it saves me a lot of time. So that's what we're going to do here. We're going to find one angle, and we're going to see if those lines are perpendicular to one another. And again, we talked about perpendicular lines make opposite reciprocals. So, what angle do you guys want to find? Which one? Huh? A. Why not? Everyone has chose A today. Good for you. Way to stick with the course. All right? So we're going to find angle A. Well, what 2 segments make up angle A? First one being AB. Second one being AD. Those 2 make up that angle. We're going to have to find the slopes of those lines. Let's do AB first. If I had to ask you directions how to get from A to B, what do I have to do? How do I get there? Up 3. 1, 2, 3. I agree. So my rise is 3. How far do I run? Again, went up, went positive. Where do I run? 1, 2, 3, 4, 5, 6, 7. Ocho. Does 3 over 8 reduce? 3 over 8 reduce nice and neat? Good one. Leave it like that. Let's figure out what AD is. I'm going to start left to right. How do I get from A to D? What do I need to do? Go down. 1, 2, 3, 4, 5, 6, 7, 8. Because I went down, what happens to that sign? Negative. Negative 8 over 1. Hey, 3. What do you notice about these slopes? They're perpendicular. Opposite reciprocals. One's positive, one's negative, and they are flipped. That's the reciprocal part. So is this a rectangle? C. C. All right, it's a rectangle. Yes. It's a rectangle. Why? Right angles. It has 4 right angles. Awesome. All right. Again, it has because it's 1 right angle, I've got 4 right angles. Moving on to number C. Determine if ABCD is a rhombus. Is it a rhombus? What does it mean to make a rhombus? What do rhombi have? Yes, Chloe. The diagonals are perpendicular. So we're going to have to find the slopes of those diagonals, see if we have opposite reciprocals again, and then we would know if this is a rhombus. So let's find AC. Go back to my up there and addition code. Let's find the slope of AC. Then we're going to find the slope of BD. Why not? Again, that's sometimes a little hard to visualize, but just make sure you're watching and see what's going on. So to get to A to C, what directions do I have to go to get to A to C? What do I need to do? Down. 1, 2, 3, 4, 5. Because I went down, that means I did negative 5. Let's count over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. Does negative 5 over 11 reduce? No. Close. Let's go. All right, we found AC. It's negative 5 over 11. Let's find BD. I know it's BD, but I like to go left to right. Just keep things positive. If you could, just make sure you go up or down first. I'm starting at D. If I go from D to B, what do I need to do? Up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I went up 11. How far do I go over? 1, 2, 3, 4, 5. Are these opposite reciprocals? One positive, one negative? Fraction flip? Yes, it is. So do I have a rhombus? Yes. Rhombus. What's my reasoning? What's my reasoning for this? The diagonals are what? Are perpendicular. Diagonals are perpendicular. One more down there at the bottom. Is this a square? Is it? It is a square. Why? It has a property of rectangle and the properties of a rhombus. So yes. I would say yes, it's a square. My reasoning would be 4 right angles and diagonals are perpendicular. Those two things. One little thing someone asked earlier, I think Ms. Baker talked about it. If not, I'll talk about it again, just rehash it. What if I did this whole thing and I found out it's a parallelogram? And I went through and I went through and did this thing. I didn't get opposite reciprocals for a rectangle. Could it be a rectangle if these weren't opposite reciprocals? No, they would not be. Does that mean I stop and leave nothing there? No. I have to check to see if it's a rhombus too, because it could be a rhombus and not a rectangle. Going back here, if it's not a rectangle, could it be a square? No, because all squares are rectangles. So you still have to piece those together. Even if I went through, you don't leave this blank, you did the math up here and said this is not a parallelogram. You still have to explain that this is not a rectangle because it's not a parallelogram. This is not a rhombus because it's not a parallelogram. This is not a square because it's not a rectangle or a rhombus. You need to explain those things if it's a no factor. If it's yes, keep going, explain. Question? Question? Ready, set. This guy.
Number 11 got cut off. We are finding the midpoint of CD, and where C is at negative 10.7, and D is, off memory, 8.3. Okay. Well, we're trying to find the midpoint. It's similar to what you did in 10A. What do we have to do with our x values? Oh, we know we're going to divide by 2. You are correct. We only have to do the x values before we divide by 2. Do what? Add them. Good. We add our x's and divide by 2. Do the same thing with the y's. Add our y values, divide by 2. So when we do that, negative 10 plus 8 is 32. And what is 7 plus 3? Always look to reduce your fractions. That's negative 2 over 2, simplify down to negative 1. What is 10 over 2, simplify down to 5. So that is the midpoint of that segment. Okay? Something similar like that will be on your test as well. Questions over that? Questions over